So we've been looking at voting methods and weighted voting. So participants or players in the voting coalition, they have more weight than others. We just talked about the bonds-off power. And now we're looking at a different method, which is called the Shapley-Shubik Power Index. So I'm just going to kind of read through this which is on your screen, and kind of talk through it at the same time. So Shapley-Shubik takes a different approach to calculating the power. Instead of just looking at which player can form a coalition, Shapley-Shubik decided that all players form a coalition together. The order of players join a coalition is important. This is called sequential coalition. So when we were looking at the bonds-off power, we had, okay, a player comes in and they vote for a motion, and then it either passes or it doesn't. We looked at all these winning coalitions, different subsets of the different players coming in. And then we looked at the winning coalitions and we looked at, is that player pivotal or not? If we took that player out of that coalition, would it still be a winning coalition? If we took that player out of the coalition and it was still a winning coalition, we said he was not pivotal. But if we took a player out and that winning coalition no longer wins, then we say that player is pivotal. It was possible to have multiple pivotal players in the bonds-off power. So with a Shapley-Shubik power index, they're saying we're not going to look at different subsets of how we could make up that set. We're going to look at all the sets and the different ordering that we can put those players in. So it's going to be different if player one comes in first or a player comes in third. And person is going to be called a pivotal player, which I haven't read to yet, if they are the person that comes into the coalition and they have knocked it up to be that coalition to be a winning coalition. So only one player can be a pivotal player in a coalition. Okay, so let me just go back to where this was. So instead of looking at a player leaving a coalition, like the bonds-off method, this method examines what happens when a player joins a coalition. When a player joins the coalition, the coalition changes from a losing to a winning coalition, then that is a player known as a pivotal player. So they're the one that changes from a losing to a winning coalition, that person coming in. And order matters for Shapley-Shubik. Now we count up how many times each player is pivotal and then divide the number of sequential coalitions. Note that in reality, when coalitions are formed for passing a motion, not all players will join the coalition. The sequential coalition is used only to figure out the power each player possesses. Okay, so let's look at the following example. So, and we know how to read this weighting voting system. We looked at this last week. So as an example, suppose you have a weighted voting system as follows. So we have 17. This first number, we remember, was the quota. So what needed to be met in order for the motion to pass? So 17 or higher would make this motion pass. And then the numbers after that were the weight of each player. And we went from the highest weighting player, calling them player one, that would be weight one, their weight in the voting system. 7 would be the weight of player 2, and 3 would be the weight of player 3. So in here we have 3 players that are voting. So one possible sequential coalition is the following. And so we would list it as piece of 1, comma, piece of 2, piece of 3. So when we write it this way, this is in the order that they're coming in. So this is telling me piece of 1 came in and said, okay, I want to pass this. Then they're looking at piece of 2 coming in saying the second member saying, okay, yes, I want to pass this motion. And then this piece of 3 would be the last one. Okay, so which means that piece of 1 joins the coalition first, followed by piece of 2 joining the coalition, and finally piece of 3 joins the coalition. When player 1 joins the coalition is a losing coalition only with 12 votes, right? So player 1, right, we have 12 votes for player 1. We usually don't write it like this. We have then 7 votes comes in. And so that weight of that coalition now, remember we would add the weights together. So that would be 19. And 19 would pass the winning coalition when we had the quota was 17. So in that case, because it went from player 1 who didn't win this coalition by themselves to player 2 joining and then winning, we're going to call player 2 the pivotal player. Usually we'll look at it, we don't put those numbers there. We would write it piece of 1, comma, piece of 2. We underline the pivotal player of the coalition. And there's only one pivotal player of a coalition. Okay, so let me just go back. So when player 1 joins the coalition is a losing coalition with only 12 votes. Then when player 2 joins, the coalition now has a rough votes to win, 12 plus 7, which is 19 votes. Player 3 joining doesn't change the coalition's winning status, so it's irrelevant. Thus, player 2 is the pivotal player for this coalition. And another sequential coalition, we could write this as piece of 1, piece of 3, and piece of 2. So let's look at it. If we had, and without reading through, and then I'll go back through. If piece of 1 was the first player to join the coalition, remember they only have 12 votes, quota is 17, so they didn't win. So we're not going to underline it. Piece of 3 comes in next. Well, they have the 12 votes for piece of 1 plus the 3 votes for piece of 3. 12 plus 3, that's 15 votes. That doesn't meet the quota, and so he doesn't make it a winning coalition when he joins second. And now if piece of 2 comes into the coalition, they've now upped it from 15 points plus 7 that they bring along, which is 22 points. And 22 points passes the motion because the quota was 17. And so we're going to underline piece of 2. So this is telling me the order that they would be coming into the coalition. And then the underline is telling me which is the pivotal player, which one made it go from the losing coalition to a winning coalition. Let's see. A couple questions coming up. So let me just read it. And I think some of you are answering that. So someone said in every coalition, is there only one pivotal player? So that's correct. So when we're looking at the Shapley Shubik method, there's only going to be one pivotal player in that sequential coalition. The other thing with this one is the sequential coalition has to have every single player listed, even if they wouldn't have came in to pass the motion. And then we're looking at just that one that would have jumped from not winning to passing it. And that makes them pivotal. Okay, so piece of 2 in that case made it pivotal, making it a passing that motion. So let me just kind of read what it says below. So when player 1 joins the coalition is losing coalition with only 12 votes. Then player 3 joins, but the coalition is still losing coalition with only 15 votes. Then, doesn't say, is the pivotal player of the coalition. Oh, sorry. Then player 2 joins the coalition, is now a winning coalition with 22 votes. So player 2 is the pivotal player for this coalition as well. Okay, this is where it can get really tedious. Same thing when we were looking at the bonds off power, when there were a lot of players involved, and writing all the different subsets of winning coalitions could have taken a while. And here, when we have N players and we have to list all the different possibilities of how different people can come in, that can also become really tedious. So how many sequential coalitions can there be if we have n players? So let's look at 3 players first. So if we have this sequential coalition for 3 players, piece of 1, piece of 2, and piece of 3 are the following. So usually what I do is I start with the first player and I list it in order, and then I start changing things around with my second player. So in this case, I have piece of 1, piece of 2, and piece of 3. So keep piece of 1 there, change piece of 2 and piece of 3. So piece of 3, piece of 2. So I've had all the combinations right there with my player 1 being first. So now I go to my player 2 being first and look at my combinations. Well, player 2 first, then player 1 can come in, and then player 3, or player 2 first, then player 3, and then player 1. So now we've looked at all the combinations where player 2 was first, and so I go to player 3 and look at those combinations. So if player 3 comes first in to pass, then player 1, then player 2, or it could be player 3, player 2, player 1. So just noticing the different notation between the Bonds-off power and the Shapley-Shubik method. So when we were looking at the Bonds-off power and we were looking at the different subsets of the winning coalitions, we used these curly brackets, and I don't even know what these are called. And so for the Shapley-Shubik coalitions, they kind of look like greater than and less than signs. We list them that way for our sequential coalitions. So notice when we had 3 players, we had 1, 2, 3, 4, 5, 6 different ways that we could write the sequential coalitions. So there's 6 sequential coalitions for 3 players. Can we come up with a mathematical formula for the number of sequential coalitions? Well, you betcha we can. So for the first players in the sequential coalition, there are 3 players to choose from. Once you choose one of the first spot, then there's 2 players to choose from. Once we've chosen a player for the second spot, then there's only third spot, we only have 1 player to choose from. And so notice that we can write this as there's 3 people times 2 people times 1 people, which is 6. So it looks like if we had n players, then basically what we can do is take how many players there are times getting 1 less number of players, then take 1 less times that times 1 less until you get down to 1 player. So there's actually a way to write this. This is the same thing as writing n with an explanation point. It's called n factorial. So this expression is called n factorial, which is denoted with a and then an exclamation mark. So most calculators have this factorial button on them now. And now we can have a concept for calculating the Shapley-Shubik power index. So I pull this from different material, and they do a little bit different notation in your book. And so for the Shapley-Shubik index, this is where we look at, and they use SS for Shapley-Shubik instead of just an S. So SI, this is equal to the number times player, and I can put player as P, player I is a pivotal player. And all the sequential coalitions. How many times are a pivotal player? So n is the number of players, and n factorial is the number of times or how many ways that we can write those sequential coalitions with those n players. Okay, so let's look at an example. So again, let's say we have the 17 is our quota. Player 1 has weight 12, player 2 has weight 7, and player 3 has weight 3. And we want to determine the Shapley-Shubik power index for each player. Okay, so first we want to write out each sequential coalitions. And then when we're going to go through each sequential coalition, and we're going to underline the one player that made it from a losing coalition or motion to a winning passing motion. So take a moment and write down each of them. So we have piece of 1, piece of 2, piece of 3 is one of them. Then piece of 1, piece of 3, piece of 2 is one. Piece of 2, piece of 1, piece of 3 is another one. Piece of 2, piece of 3, piece of 1. Then we have piece of 3, piece of 1, piece of 2. And then last but not least, piece of 3, piece of 2, and piece of 1. So player 1, first sequential coalition, player 1 comes in. They only have 12 votes. They do not make this a winning coalition. Player 2 adds a coalition with their 7 points, and 12 plus 7 gives us 19. And so they are a pivotal player because they just made it the winning coalition. Piece of 3 comes in, it's already winning, so they don't have any effect. So really we just have to find that one that wins, and then we don't have to look at the other ones. So again, piece of 1 comes in, it's not a winning coalition, but piece of 3 comes in. So they add 3 votes to piece of 1's 12, that makes it 15. They are not a winner. And so the third piece of 2 comes in, and they add their 7 votes, and they make it a winner, so piece of 2. So now let's look at piece of 2 coming in first. They only have 7 votes. So really all of these I know the first player coming in is never going to make this pass. So let's go to the second person. So piece of 2 plus piece of 1. Well, oops, that's the 7, then plus 12. That gives me that piece of 1 is the pivotal player there. Piece of 2 is 7 plus piece of 3, which is 3. That makes it 10, not winning. So it's that third player coming in. Oops. Piece of 1 is also making that one a winning coalition, so they're a pivotal player. So piece of 3, piece of 1. So 3 plus 12 doesn't make it a winner. And then piece of 2. So 3 plus 12 is 15, plus 7 is 22. Piece of 2 is a winner. So piece of 3, piece of 2, piece of 1, piece of 3, and piece of 2, that's 7 plus 3 is 10. Did I add something wrong before? But a piece of 1 is making it. So notice that for the Shapley-Shubik index, for player 1, this is equal to, we'll go through and see how many times they were the pivotal player. So if we go through, they were pivotal player here once, then twice, then 3 times. All over, oops, actually, let's just keep it there. So that's their number of times they're a pivotal player. Sorry, and this should be S1. So if we look at the Shapley-Shubik index, how many times pivotal player 2 was a pivotal player? Well, in this case, that was 1, 2, 3 times. And poor player 3, they were never a pivotal player, so 0 times. So they denote the Shapley-Shubik index with the Greek letter rho. I believe it's rho. So I'm going to note it, this rho sub I, this is equal to SSI all over n factorial. Again, where n is equal to the number of players. So in our case, and I'm just going to go through it again, 6 factorial. I'm sorry, there's not 6 players. I know I'm going to get 6. 3 factorial. This is equal to, take that number that we're starting with, which is 3, multiply it by 1 less than that, which is 2, multiply by 1 less than that, which is 1, until you get to 1, you stop. So 3 times 2, which is 6, times 1 is 6. So for player 1, the Shapley-Shubik index is 3 all over 6. So this is equal to, and they want you to reduce it 1/2. So the Shapley-Shubik power for player 2, that is the number of times they were a pivotal player, which was 6, all over the number of sequential coalitions, which is, sorry, they won 3 times, all over the number of sequential coalitions, which is 6, which gives us 1/2. And the Shapley index for player number 3 is 0 over 6, which is 0. So they have, player 1 has 50% of the player 2 has 50% of the player, and player 3 has 0% of power, according to the Shapley-Shubik index. So technically, no power, can't change anything. We call player 3 a dummy variable. They might feel important because they have 3 votes, but really they don't matter whatsoever. So any questions on that? Okay, so we're just going to go through more examples.
I have a quick question.
Mm-hmm.
So Shapley-Shubik power is going to be represented on a percentage, right?
Yes.
Which is different than the other one, which is a fraction.
Just see how my math lab wants it. Let me just go down and see if I have an example. Actually, let me see. It's a good question. The videos that I was watching last night, they ended up putting them into percentage. Yeah, I don't have that right in front of me right now. Yeah, they're putting it in percentage in the book. Yeah, it's a good question.
Thank
Any
you.
other questions? Yeah. So actually, let's actually this is not the same one, but this is a good review. So when I had pulled out these notes, I had thought I was going to get through this last week, and I was just lecturing on the Bonza power index. But this is kind of a good review and for you of what we did last week and the other method that we were looking at for weighted voting system. So for the following system, let's say we have 7 is our quota, player 1 has 6, a weight of 6, player 2 has a weight of 4, and player 3 has a weight of 2. Okay, so remember the Bonza power index. We looked at, first thing we did was we looked at all the coalitions. Sometimes we just skipped and we went to the winning coalitions to determine which one of the winning ones are winning and then which ones are losing. And then we determine the number of critical players in each coalition. So for instance, we could have a coalition basically with it's just one player that comes in. So if it was just player 1 that was in that coalition, they would bring in just a weight of 6, but the quota is 7. So this would be a losing coalition and so there's no critical players. If we were just, and so the same thing's going to happen. If any one player coalition, never is going to win. So in this case, player 2, it was just them in the coalition. That would be a weight of 4. It doesn't meet our quota, so it's losing. Piece of 3. We saw that this has a weight of 2. Again, it's losing. So a lot of times it's just a waste of time to have to go in there and putting the losing ones. But just kind of as a reminder, I'm going to just list them off on this case. So we know that one player coalitions aren't winning, so let's look at all the player 2 coalitions. So we could have player 1 and we can have player 2. We're not talking about order here, so this could be the same thing as representing player 2 and player 1 coming in. So in this case, if we have player 1, that's 6, plus player 2, which is 4, and this gives me a weight of 10 for that coalition. We know that our quota is 7, so this would be a winning coalition. Well, if we remove player 1 from that coalition, player 2 alone cannot win. And so they are pivotal in that, or critical, they call them critical in this case. They're a critical player. And so player 1 is considered critical. But the same idea, if I took away player 2 from that coalition, piece of 1 can't win by themselves. And so piece of 2 can't win by themselves, so player 2 is a winning coalition. So there's another possibility of a 2-player coalition, player 1 and then player 3. Let's see if this is winning. Well, player 1 has 6 votes, plus player's 3 votes, which was 2. This is equal to 8. So 6 plus 2 is 8. That's over 7, and so this is a winning coalition. So again, if I removed either one of those players, it would be losing. So each player in that coalition is critical, player 1 and player 3. Well, that's all the 2 coalitions that could happen with player 1. So now I move down to player 2. Player 2 could also be coming in with player 3. Doesn't matter order in this case. We're not looking at order for bonds off power. And let's see what their weight is. Well, player 2 had 4 votes, plus player 3 with 2 votes. So this gives me 6 votes. And this is a losing coalition, so none of those people are pivotal players. So that is all the combinations of 2 players that is possible. And so then you go to all the possible things with 3 players, player 1, player 2, and player 3. So in this coalition, if all 3 of them voted for it, didn't matter what order they came in, player 1 had 6 votes, plus player 2 is 4, plus 2, this 2, I know this is winning, this is 12, and this is a winning coalition. But we need to see which ones are pivotal or critical. So if we took out player 1 from this coalition, that would remain player 2 and player 3. Looking above, player 2 and player 3 is losing. So they need player 1 in here for this to be a winning coalition. So we would say that player 1 is pivotal or critical. Okay, so now let's see if player 2 is critical. We know that this is a winning coalition. If we removed player 2, is it still winning? Well, player 1 and player 3 up here, notice, is still winning. So player 1 and player 3, they don't need player 2. They're not a critical player. And then same sort of idea, let's see what happens if we just remove player 3. Well, if we remove player 3, they're still going to be winning. So they're not pivotal. Okay, so once we've determined who was a critical player, we looked at the bonsai power index. And so B sub 1, so they were a pivotal player 1, 2, 3 times. player 2, they were a critical player just once. And player 3, they were also a critical player once. And so then we looked at, it was like a beta. This is where we looked at their bonds-off power index. I'll just remind you. So B sub I, this was equal to the number of times they were a critical player all over T, where T was equal to the total number of critical players. From all the coalitions, from all winning coalitions. Okay, so in this case, this would be 3 all over. And if I look at T in our case, we have 1, 2, 3, 4, 5. So they would have 3/5. The bonds-off index for player 2, they have 1 out of 5. And the bonds-off power for player 3 is 1 out of 5. Let's just pause for a second while you guys have a chance to write anything and come in and chime in if you have a question. Okay, so let me scroll up. The B1 or BI, that stands for the number of times they were a critical player in all the winning coalitions. So the B sub 1, and then there's like the beta where it's more of a curly. That is the bonds-off power index, how much weight they have in that voting coalition, or their voting power in that voting system. Does that answer your question? Okay, so to find the Shapley-Shubik for the index of each player, the first thing we were going to list is all the sequential coalitions and then determine the pivotal players for each thing. So this was actually for part B. Let's me scroll up. So let's do the same thing we just did for the bonds-off power for each player in that coalition. Let's do it and see what we get with a Shapley-Shubik. I don't have my keyboard on there. I don't know how to do that. So let me do this instead. Okay, so there's 3 players. So we have to list all the different combinations of 3 different players for the Shapley Shubik. And so for 3 players, and all 3 players we're assuming comes in for them, we can have you first player 1, then player 2, and then player 3. Or we could say player 1 comes first, and let's just swap the order for player 2 and player 3. So then player 3 is second, and then player 2. So now we've looked at all the different combinations of player 1 coming in first. We're going to look at the combinations of player 2 coming in first. So player 2 could come in first, then player 1, and then player 3. Player 2 could come in first, and then let's swap the order of player 3 and player 1. So it would be player 3 and then player 1. Okay, so those are all the combinations of player 2 being able to be the first person coming into that sequential coalition. And so now go to the next player, which is player 3. So player 3 could be first, then player 1, and then player 2. Or it could have been player 3 first. Let's swap the other 2, then player 2, and then player 1. So let's go down the line and figure out which one is the pivotal player for the sequential coalition, and there's only going to be one. Here again, the winning coalition or winning quota, we need 7 to pass the motion. So if player 1 comes in first with 6 votes, that's not a winning, they didn't make it a winning coalition, and so they're not pivotal. Player 2 comes in with their 4 votes. So 6 plus 4 is 10. That makes them a pivotal player. So now piece of 1 has 6 votes, and then piece of 3 comes in with their 2 votes. That makes them a pivotal player. So piece of 3 is the pivotal player there. So piece of 2 first with 4, then piece of 1 with 6. That makes piece of 1 pivotal there because they make it a winning coalition. Piece of 2 with 4, then piece of 3 with 2. That's only 6. Piece of 3 doesn't make that passing. So they need piece of 1 to make that a passing one. So piece of 1 is the pivotal player there. Piece of 3 and then piece of 1. So piece of 3, that's 2. Then piece of 1 with 6, that makes an 8. So that makes them pivotal player 1, the pivotal player. Piece of 3 with 2 plus piece of 2 with 4, that's 6, not winning. So player 1 is the pivotal player. Move that down. Okay, so notation wise, so let's look at all the times that player 1 was a pivotal player. And so looking at this, they're a pivotal player here, 1, 2, 3, 4 times. So this is 4 times out of the number of times in factorial, which there's 6 different coalitions. 6, which is 2/3. Oops, I went too far. So the SSI is just the 4. I might as well do their index. Kind of like a funky R sub 1. So this is the 4 out of 6, which reduces to 2/3. If I did that, that's going to give me approximately 66.7%, I believe. Know that. Yeah. Okay, so looking at the Shapley Shubik Power for player 2. So going through here, how many times were they a pivotal player throughout? And that was only once. And so their Shapley Shubik index is 1 out of 6, which is approximately 16.7%. Player 3, they have also won once, or made them a pivotal player. And so the Shapley Shubik index is 1.6, which is approximately 16.7%. Just wanted to see if I could look at the difference. So 3/5, let's just look at that. It's 0.6. So about 60% if we converted these into percent, or that actually equals 60%, it's not approximate. 1/5 is 20%. The same voting coalition, player 1, player 2, player 3, same weight. Just again, just get rid of this if I can. And I just, I don't know what I did. I don't know if I can move that now. But basically, they're pretty similar. And I just like messed up my whole screen by doing all that. So any questions? I can pull everything down. So I'm just going to go to a different page so I don't have to start playing around with it. Okay, let me also go back and grab one other thing. Which will save us a lot of time. Okay, we're looking at the Shapley Shubik power distribution of the following. So this is a 4-player voting party. We have player 1 with 12 for this part A, player 2 has 6, player 3 has a weight of 2, and player 4 has a weight of 1. So for Shapley Shubik, the number of possible coalitions, sequential coalitions, was n factorial. So n factorial, and so in our case, n is equal to 4 players. So if we looked at 4 factorial, this is telling me I need to multiply 4 times 1 less than that, which is 3, times 1 less than that, which is 2, times 1 less than that, which is 1. So if I go through and multiply this out, well, 4 times 3 is 12, and I still have times 2 times 1 left. And 12 times 2, that's 24, and 24 times 1 is 24. So there's 24 different possibilities of writing these all out. And so if we have it and we wrote them all out, this is the following. So we have player 1, player 2, player 3, player 4. Player 1, let's just list all the ones with player 1 first. Then we have player 1, player 2. Let's just swap the last two. Player 4, player 3. We have player 1, player 3, player 2, player 4, player 1, player 3, player 4, player 2, etc. And so let me copy this real quick. Sorry, let me move this down here because we're going to use it again. So let's go through and let's just talk about this with this first coalition where you need 12 players or 12 votes to be winning. Okay, notice that player 1 has 12 votes. So if they're the first player, they pass it, no doubt. So I'm just going to go highlight or underline the one that is the pivotal player. So player 1 is pivotal for that first coalition of P1, P2, P3, P4. So for the coalition, player 1, player 2, player 4, player 3, player 1 wins. Player 1 is good again. So whenever player 1 is first, they're going to be critical. And before we even go on, let's talk about the other 3 players. Notice with their weight, these other 3 players, 6 plus 2 is 8, plus 1 is 9. These 3 players can't win the coalition by themselves. So really, if that was the case, whenever player 1 is the last player, that would also make them a winning coalition. Okay, that's player 1. Oops. Looks like I have a little bit of an error in here. This right here should be 2. Looks like I have a 2, 3. Actually, before I do that, and I just, so I think I highlighted, no, I didn't highlight all of them when you have player 1 as the last one. Okay, then let's think if we have player 2 and then player 1. It still doesn't make sense. If never can any of these be the person that makes this jump over? So player 2, that would give me 6 points, and then player 1 comes in. Player 1 is going to be the one that again knocks it over. Player 2, player 1, none of these people. So player 1 in the second position is always going to win. Basically, no one without player 1 player 1 is always going to be the one changing the tides. Okay, so this is where we would call player 1, remember, a dictator. So the Shapley Shubik Power player 1, well, there's 24 coalitions. And they have 24 over 24. That means player 2, player 3, player 4 all have 0. And their weight then is 0 over 24. Which is 0. Okay, so really that quota doesn't make sense. It's just making that player one the winning, a dictator, and none of the other players have anything to say about it. Okay. So let's change that coalition so that the quota is a little higher and see if that affects things, which hopefully it does. So now let's look at it when our quota is now 14. So this time player one comes in first player, they have 12 on their weight, and so they're not gonna be the pivotal player. So basically if player one comes in and they can't be a pivotal player, then any of the ones that have less weight can't come in as the first person in the coalition and be pivotal. So we can kind of skip the first person. So let's look at, well, player one and then player two. Well, 12 plus 6, that's 18. That surpasses 14. Let's just see if player one and a second player would always pass it. So if I had player one and player three, that's 14, that would pass it. But player one and player four is 13, won't pass it. Okay. So if I have player one, then player two is pivotal. Player one, player two, and rotating the last two players, player two is still pivotal. Player one and then player three, that is 12 plus 2, that's 14. Player 3 is pivotal. Player 1, player 3, that's still pivotal. So rotating the last two didn't change anything. But player 1 and player 4, we just said 12 plus 1 is 13. Player 4 is not pivotal there. But when player 2 comes in with their 6 votes, they bump it over 14. So they're pivotal. So player 1, player 4, again, won't be pivotal. That third player is the pivotal one when player 1 is first and then player 4. So now going to player 2 and then player 1, we know that 2 and 1 together, 1 would push them over the edge with 18. Player 2 and player 1, again, player 1 would push them over the edge. Player 2 and then 3. If I have player 2, which is 6, plus player 3, that's 8. 8 is not pivotal. Make it pivotal. Then if I add player 1 in there, well, that 8 plus that 12, that player 1 hits pivotal. 2 and 3 again, that was 8. And if I take player 4 and add in 1 more, that makes 9. They're not pivotal. So player 1 makes it pivotal. Player 2, so that's 6, plus player 4, that's 7, plus player 1, so 7 plus 12, player 1 is needed to make that a winning coalition, so they're pivotal. So 2, 4, 3. Well, 2, 4, and 3, 6, 1 is 7, 7 plus 2 is 9, we need player 1. So player 1 is pivotal. So player 3 and player is not pivotal by themselves, but adding player 1 to it does make it pivotal. 12 plus 2 is 14. Player 3 and player 1, again, player 1 is pivotal. But 3 and 2, 2 and 6 is 8. So player 1 is pivotal, the next one. Player 3 and player 2, again, that's 8. Then with a 1 from player 4, they're not pivotal, that's 9, we need player 1. So none of these I see can make it without player 1. So basically if player 1 is ever at the end, they need that player 1. So let's just highlight them. Okay. So looking at the next case scenario. Player 4 and player 1, that's too small. And so the third person, player 2, would make it go over. So player 2 is pivotal. 4, 1, and then 3. 4 and 1 is 1 plus 12 is 13. They need, 4 and 1. Yeah. Plus player 3, which is 2. They need them, and player 3 is pivotal. Player 4 first is 1, plus player 2 is 8. Plus 12, player 1 is pivotal. 4, that's 1, plus 2 is 3. 3 plus the 12, player 1 is pivotal. And the last one I missed over here, player 3, 4. So that is 3 and 4 is 3 points plus player 1, which is 12 points. Okay, so number of times player 1 was the pivotal player. Maybe this would have been better with different colors, but we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so their Shapley Shubik index is 16 all out of 24. That reduces, they both have 8 in common. 8 goes into 16 twice. 8 goes into 24 3 times. The Shapley Shubik index for player 2. Well, first count how many times they're a pivotal player. So player 2 have 1, 2, 3, 4. So their Shapley Shubik index is 4 out of 24. That reduces to 1/6, which is approximately 16.7%. So player 3 so I have 1, 2, 3, 4. So they have the same power as the second player. 4 over 24, which is 1/6, which is approximately 16.7%. And the last player, if you notice, they never put it over. So 0 times were they a pivotal player. So their Shapley index is 0 over 24, which is 0%. And so in that case, that fourth player, they would be considered a dummy player. I'll give you a couple seconds to write that down, and I will post another problem. Okay, so for our last example we're going to look at today, we're going to use information that we get from the Bonsoff Power Index and try to figure out the Shapley Shubik sequential coalitions and also the player's power. So in the following, we have in a weighted system with 3 players, we have the following winning coalition. So player 1, player 2 is a winning coalition, and then player 1, player 2, player 3 is a winning coalition. Well, let's kind of talk about this. Okay, so let's go through and let's first write down all the possible sequential coalitions for the Shapley Shubik Power. And so we could have player 1, and then player 2, and then player 3 come in. Well, above, if I knew that player 1 had enough weight to be a winning coalition, then I would have this up here in the bonds-off power. I would have that in those possible winning coalitions. So I know piece of 1, it's impossible for that to be the pivotal player. But I know when piece of 2 comes in here, they're going to make it pivotal. And so in this case, they're the pivotal player here. Okay, so let's look at player 1 and then player 3 coming in next. Well, if they were a pivotal player, then that would have been a winning coalition up here. So I know piece of 1 and piece of 3 together can't win. And so the next player coming in, piece of 2, that would make them pivotal. Okay, so those are on the combinations where piece of 1 comes in first. So now I'm looking at all the combinations that are possible with piece of 2 being the first player coming in. So I have piece of 2, then I could have piece of 1, and then piece of 3. Well, again, I know 1 and 2 is a winning coalition. 1 can't, or 2 can't do it by themselves, but once piece of 1 comes in, I know that that's passing because of the information up there. So player 1 is a pivotal player there. Player 2 could be first, then player 3 comes in, and then player 1. Well, 2 and 3 can't win it by themselves, or it would be a coalition up here. So player 1 is pivotal. So player 3 is first, and then player 1. Well, player 1 and 3 can't do it by themselves. So they need player 2 to come in. Player 2 is pivotal. Player 3 first, and then player 2. Again, they can't do it by themselves. Player 1 comes in, they would be pivotal. And so we listed all the sequential coalitions and we identified each of the pivotal players in each one of those. And then from that, we can now decide what the Shapley Shubik power of the distribution of the weighted voting system is. So player 2, or player 1, let's do that first. They have 3 times that they're a pivotal player. 3 times out of the 6 possibilities is a half. Player 2 also was a pivotal player 3 times, and so their Shapley Shubik index is 3/6, which is 1/2. Poor player 3, they're never a pivotal player. They don't have any weight, so they have 0 out of 6, which is 0. Okay, so we were able to take information on the bonds-off power index or the winning coalitions of that, and then figure out what the Shapley Shubik sequential coalitions could look at like and who would win and who was the pivotal player in each case.